This is a MOSFET, and inside there's just a tiny piece of semiconductor. But these components are so important and we find them everywhere. MOSFETs look something like this. They come in many shapes and sizes. They are represented with symbols like these in engineering drawings. I'll explain those later in the video. MOSFETs have 3 pin terminals, and we call them the gate, drain, and source. Sometimes these terminals are in a different order, but we can check that on the manufacturer's datasheet, and you can find that online using the part number which is printed on the front of the component. I want you to imagine water flowing through a pipe. We can block the flow with a disc. There is a hole in one side of the disc, so if we slide the disc across, we can let water flow again. The disc is spring-loaded, and so it is normally closed. Another pipe connects to this disc, and the pipe is filled with water. If a small pressure is applied to this pipe, it won't be enough to move the heavy disc. But at a certain pressure, the disc will begin to move and allow the water to flow. As we increase the pressure, the disc fully slides across and the water can fully flow. But if we remove the pressure, the gate closes and the flow of water stops. This is basically how the MOSFET works. If we take a lamp and we connect it to a power supply, it will turn on. If we insert a switch, we can manually control this. If we insert a MOSFET between the drain and source pins, the lamp will remain off until we apply a voltage to the gate pin. And that means we can use a controller or sensor to turn the lamp on automatically. But if we vary the voltage on the gate pin, we can vary the current flowing through the main circuit. And that means we can also dim the lamp as well as turning it on and off automatically. Instead of a lamp, we could control a relay, and the relay can control an AC circuit. And that means we can turn an appliance on and off automatically and even remotely. We could also control the speed of a DC motor. The motor can rotate forwards or backwards depending on how we connect the power supply. But using MOSFETs, we can automate and change the direction. Some electrical loads have a high current, which causes the MOSFET to heat up. So we attach a heatsink, which increases the surface area with the air and helps to cool it down. For example, this DC power supply uses MOSFETs. The MOSFETs are attached to some very large heatsinks. Without them, they quickly rise in temperature. We can turn MOSFETs on and off extremely fast by using a pulse width modulation signal. That lets us efficiently control the brightness of an LED light. We have an entire tutorial on how to design and build that circuit, links down below for that.